Right, guys, well, let's get started on our algebra. Please remember, we have been doing algebra, and as Botale said when reading out the rules, if you have missed something, you need to go back and rewatch the videos. Okay, so what we've spoken about so far is some very basic examples of algebra, incorporating some exponents. We've also spoken about distribution and how we deal with distribution in our simplification. Sure, my English today. And then what we are going to chat about today is we are going to see if we can now follow and apply everything that we've learned so far to make sure that when we get slightly more complex questions, we are following the order in which our work needs to be done. All right, so sorry. Oh my gosh, I'm clicking the wrong lessons, right, losing my mind. So what we're going to have a look at today, like I say, is order of work. Now, you might have heard order of work before because I often use this phrase. Don't know what happened to the D there, but anyways. But what this refers to is making sure that we are following bodmas or bedmas. Essentially making sure that we are doing each operation in the correct order so that when we simplify our expression, we have correctly simplified it to get our answer. So remember we spoke about on Monday what terms are, and again, we're going to just refresh our minds for ourselves. Terms are the parts that make up our expression, and they are separated by plus and minus signs. That's not how you spell separated. We don't look at the plus or minus signs inside a bracket, nor do we look at the plus or minus signs inside a fraction. So if we look at this very first expression, this whole fraction is my first term. This plus sign is separating the first term from the second term, which is the 2xy times the bracket. And this minus sign is separating my second term from my third term, which is at minus 5x squared y. So plus and minus signs separate my terms. And I need to know what term is which. So I need to know how many terms I'm working with and what my terms are. Because in order for me to apply bodmas, knowing my terms is very important. Okay, now the reason for that is because according to bodmas, we need to deal with any brackets first. We do have brackets here. I can't simplify them, but we always double check. And then I need to go on to the division and the multiplication. So what I can see is that in term 1, I've got division because I've got a fraction. And in term 2, I've got multiplication because I've got distribution. And so those things need to happen first before I start adding and subtracting. So what we want to do here is we want to take our first term and we want to simplify it. Okay, so if we have a look at our very first term and we try and simplify that, let's have a look and see what is happening specifically in this bracket, in this fraction. The first thing I'm hoping that we notice is that in my numerator, I've got like terms. I know these are like terms because they both have an x squared in them. And remember, like terms are terms that have the same exponent as well as the same variable. So these are like terms. And because they are like terms, I can add and subtract it. So minus 3x minus 2x, if we just imagine our number line quickly, if I'm already at minus 3 and I want to subtract 2, I need to move down my number line. So here I am at negative 3x squared. Minus 1 minus 2x squared. I can simplify that numerator to minus 5x squared, all being divided by negative x. I can still simplify that further, and I'll get to that in a second, but we're starting to simplify our terms as we go along. If I now look at my second term, in my second term, I see that I can distribute the 2xy to both terms. So if I do my little multiplication block for myself and I go and do my multiplication, I've got 2xy times positive x and 2xy times negative 2y. Grade 8s, Some of you are not focusing in the chat, and I'm not repeating myself. That was one of the rules, that I'm not repeating questions and statements that have been made. So please, can we focus? If I do my multiplication, positive 2xy times positive x, a positive times a positive is a positive. Remember, you can, if you want, have that invisible 1 in front of your x. You don't have to have it, but if it helps you, you can. 2 times 1 is 2. Now remember, we need to apply our exponent laws. When we've got x times x, we've got x squared. And then we've got that little y by itself. So we just write the y there. It's not being multiplied with anything, so it stays y. But because I've got x times x, I know that I get x squared. Then my second multiplication, I've got a positive times a negative, which is a negative. 2 times 2, which is 4. X times no other x, so it just stays x. But now I've got y times y, which is y squared. So I have got, or I have done my distribution from my second term. So this distributes to positive 2x squared y minus 4xy squared. So I have done my distribution for term 2. Term 3, I didn't have to do anything. There's no multiplication or division that I need to do here. So term 3 just stays minus 5x squared y. So what I start to see is that I'm starting to simplify my expression by dealing with division and distribution as I go along. Right, so if I go back to my first term, remember I said I haven't finished simplifying this yet. I still now need to do this division. So if we do a little division block here from ourselves and we just figure out what's going on, we have got a negative 5x squared divided by negative x. If you want to write it with a division sign, that's fine. It's up to you. It doesn't really matter, but remember that you are dividing. So first thing, a negative divided by a negative is a positive. Again, remember that in front of this x in our denominator, we do have a 1. So 5 divided by 1 is positive 5. And then remember again, as I said in our last lesson, whenever we have got division or multiplication of variables, we need to go back to our exponential laws. If I've got x squared divided by x, my exponent laws tell me to subtract the exponents. Now this x has an exponent of 1. So it would be 2 minus 1, which gives me just x. You can say x to the power 1, but that doesn't really change anything. So this is 5x. So this first term has simplified to positive 5x. Then I've got the rest of my terms. I haven't done anything to them. I've already simplified all of them. So plus 2x squared y minus 4xy squared. And then that last term that I couldn't do anything with until the end, minus 5x squared y. So only, and I've said this so many times, only once you have done your division and your multiplication, so only once you have dealt with these first 4 operations of BODMAS, can you start adding and subtracting. Only once that has all happened. If you start adding and subtracting before you have done the brackets, division, multiplication, exponents, whatever, you are not following the order of work correctly. And it means you're going to get your answer wrong. So now I need to look at what I have, and I need to go ahead and figure out, do I have any like terms? I just want to move this down so that I've given myself a bit more space here. So now I'm checking in my expression that I have, do I have any like terms? Now, again, we've said this many, many times now. Like terms have the same variable or variables, so x, xy, xyz, whatever. Same variable or variables, and they have the same exponent. So that means x and x squared are not like terms because they've got 2 different exponents. So when I go and have a look now at my expression and I want to identify my like terms, I see the first thing, oh, this tiny little highlighter, and that's not going to do anyone any good. So let's do this. First thing I see is that I've got terms with x in them. Now I've got no other term with just an x in it. So that is a group by itself. I can't do anything else with it. So 5x is one group of terms. If I have a look, I've now got a term with x squared y. So I want to look for other terms that have an x squared and a y in it. And I see that that is my minus 5x squared y. Very importantly, grade 8s, this minus 4y squared is not a like term to the x squared y. And the reason is because the exponents are different. Yes, I have got an x and a y, but in this case, the y is squared. With the other purple terms, the x is squared. So the exponents are not the same, and we need to bear that in mind when we're checking for like terms. So now I can add or subtract my like terms. Whoopsie. So the 5x didn't have anything with it, so it just stays as it is. 2x squared y minus 5x squared y, if we just do our little number line again for ourselves. And again, grade 8, you need to start being comfortable with adding and subtracting integers and like terms. So yes, a number line is fine, but you need to start being more comfortable with it. So we've got 2x squared y minus 5 minus 1, 2, 3, 4, 5 takes me to negative 3. So I've got negative 3x squared y. And then I've got my minus 4xy squared all by itself because it didn't have a like term. So just to show you, these are the like terms that I have simplified. Remember, the blue one and the gray one didn't have any like term pairs to it, so I couldn't actually do anything with it. And that is why they've stayed exactly the same as they are. And this is now my final answer. I have no more like terms. And so I can't do any more additional subtraction. That is it. Another thing I want to remind you is that when we add and subtract our like terms, the exponents of the variables do not change. So much writing. Okay, let's try that again. So the exponents of the variables do not change. So if you started, so for example, we started with x squared y, we ended with x squared y. We do not change the exponents. And the reason we don't change the exponents is because the only time exponents change is when we add or is when we multiply or divide terms. Right, so guys, I know that this is quite a lot of information that we've done, and like, yes, we're going to do lots of examples where we practice, but this is the type of algebra that you need to be comfortable with. This is what we're going to expect from you come the end of the year exams, and so it's very, very important that we are able to deal with these sorts of questions. So what I'm going to do is I'm going to take a second, let you take a screenshot. If there are any questions, now is the time to raise your hand. There was a question about if we have problems with other math stuff. I don't address that, no, because this is the lesson that we are doing. However, remember that you were introduced to the Watobe wizard bot in the last lesson, and so you're more than welcome to use that to ask it any math questions that you might have, and it will help you. Right, Botale, question?
I'm sorry, it might be a stupid question, but maybe.
No stupid questions.
Did we get that 5 because we added the -2 and the -3 at the top over 1?
Yes, essentially. So the minus 3x squared minus 2x squared gave us the minus 5x squared, and then we were still over minus 1x squared. Yeah. So that was through the addition of the like terms that I had there in the numerator. Good, well done. So guys, again, you're taking screenshots and you're asking me questions. I'm just going to give you another second or two to make sure that you're happy with everything that we did before we look at another example. Okay, good, grade 8. So I'm glad we don't have any questions. I'm glad we're happy. And you guys are doing really well. If you're happy with this, I promise you, algebra is going to be so much easier for you. And like I say, this was a hard example. I'm not by any means trying to like tell you that this is nice and easy and it's going to get harder. This is a hard example, but this is what you need to be able to do. And so it's important that we practice this. Okay. So let us have a look. I'm hoping we've all got our screenshots. This is what next one is obviously B, but because I moved it, it decided it wanted to fight with me. So that's okay. So let's have a look at question B. And the first thing I'm going to ask you to decide for me is how many terms does this expression have? So all I want right now in the chat, how many terms does this expression in question B have? Nice, grade 8. Well done. Okay, so we have got 3 terms here. If you're not too sure why, I'm about to explain it, so listen up. Remember, in order to identify our terms, we want to look at plus and minus signs, not inside a fraction or a bracket. So basically what that means is this entire fraction is one term. Yes, guys, I don't know why there's hands. We're now looking at a question. If you have questions, please put it on the chat. This entire fraction is our first term. Yes, there are plus and minus signs inside the fraction, but remember, we do not consider those signs when looking for terms. It is this sign outside of a bracket or a fraction that now separates my first term from my second term. And I don't really like where I put that arrow. Let's go here. So this is now my second term, the minus 4x times the 2x squared minus 3xy. This plus sign at the end here is then separating my third term and my second term. And so that 3x is my third term. So it is very, very important that we are able to identify our terms because we now need to go and double check. In those terms, is there anything I need to multiply? Is there anything I need to divide before I even start stressing about addition and subtraction? All right, so just quickly, Njabulo, I'm not too sure where that Math Wizard bot link would be. I would maybe just send a message to Linda. She might have that. Otherwise, we'll find out. Okay, so Sandra, I'm not too sure why your hand is up because I haven't asked for hand. So is there a major problem right now? Yeah? What's the problem? Sandra?
Yo, ngizandle phone isitaka sengiphakamisile.
I can hear you.
Susanna, we can hear you on our side. We just want to make sure that you can hear us, but also please put your questions on the chat. Hey, girl, because we can hear you, but now is not time for raise of the hand. Do you have any problem?
Yes.
What's your problem, Susanna?
Can you go back to the previous equation if possible?
Why?
It's just that my phone did not connect, so I didn't hear the previous equation.
Okay, I'm not going through it, but I will go back to it for like 10 seconds for you to take a screenshot, and then you can have a look at your screenshot, but I'm not going through it. I'm going through another example that will hopefully explain any confusion that you might have.
Yes, so Sisanda, also what we put here as a rule is that we don't raise our hand unless Teacher Sam says so. And also you need to make sure that you put all the questions that you have on the chat. We'll be able to actually assist you. If at any point your phone or your device is giving you a problem, please don't panic, because we are recording the lesson for you so that you can actually go and watch the lesson at your convenient time. Okay, it's just so that we can prevent to go back over again, and then the other students won't be able to progress, because we'll always have to go back to the next, to the previous slides. Okay, this goes for everyone, guys. And any question about the WhatsApp app, please make sure that you ask Watobe's administrator on WhatsApp. They'll be able to help you. Okay, any question related to that, please ask them. They will be able to help.
Thank you, Linda. Okay, yeah, so guys, ask on WhatsApp and hopefully you can get an answer there. Right. Remember, spammers, I will remove you. Right, so we are having a look at question B. If you didn't understand question A and you didn't ask your questions, put it on the chat or listen to me now. Right, guys, so we've identified our terms. You beautifully told me in the chat that we had 3 terms, so well done. Now we have to simplify each of these terms. So let's look at our first term. And what is quite nice to do is deal with each of these terms separately. Don't try and overwhelm yourself by doing everything at once. Go one at a time. So if we just look at the first term, I need to look at what I've been given in this fraction. And again, hopefully what I'm seeing is that in this bracket, I once again have like terms. The second, guys, you've got like terms in a bracket, you can simplify your bracket. So this therefore means that I've got 3xy times, now minus 4x minus 2x is a negative 6x. So I've added or subtracted my like terms and I've simplified my bracket. That is also being divided by negative 6. We'll keep simplifying as we go in, or as we keep going, but right now we've done one simplification step. I'm happy that I'm getting to a more simplified answer. If I now look at the second term, what I'm doing is I'm taking this negative 4x and I'm distributing, or I am multiplying it into my bracket. So if we do a little multiplication block again for ourselves, what we see is that we've got the negative 4x times positive 2x squared, and we've got negative 4x times negative 3xy. I'm just putting brackets there, guys, because sometimes it's a bit confusing with all the signs, the times and the minus and all the rest of it. So I'm just putting in a bracket there to remind myself that I'm multiplying by a negative. So my first multiplication, a negative times a positive is a negative. 4 times 2 is 8. Now remember your exponent rule. We've spoken about this before, but we're going to speak about it again. In your exponent rule, if you are saying x times x squared, we would add those exponents. So x times x squared is x cubed. So you need to be now combining your exponents knowledge that you already have. In our second multiplication, a negative times a negative is now a positive. 4 times 3 is 12. And now again, check your variables. You've got an x times an x, which is an x squared. And then we've just got a lonely little y there. Doesn't have anything it's multiplying with, so it's just y. So from my second term, I have got the product minus 8x cubed plus 12x squared y. So I've simplified that second term. I've gotten rid of those brackets. I'm getting more simpler, whatever the English is. We are getting more and more simpler. That sounds horrible. We're just going to pretend it's right. Alrighty, this third term, we can't actually do anything with the third term. It's just a plus 3x by itself. So it stays like that. We'll deal with it later when we start looking at like terms, but right now, we're just going to leave it. So in my first term, I can still simplify more because what I see is that I can multiply the 3xy and the negative 6x. So positive 3xy times negative 6x. A positive times a negative is a negative. 3 times 6 is 18. X times x is x squared. And of course, I didn't make my multiplication block big enough for myself, but that's okay. It is what it is. And then we've just got this y by itself. And so that means the y just stays by itself. So now in my numerator, I've got minus 18x squared y divided by negative 6. Hopefully what we see is that as we go along, we're simplifying more and more and more. We then still have the minus 8x cubed plus 12x squared y, and then our plus 3x right at the end. I'm going to deal with them, but not yet. I'm first wanting to simplify all of my terms as much as possible before I start adding and subtracting. So this last step of simplification, I now need to deal with the division. Now, what you need to remember, guys, is that when you divide a negative by a negative, you end up with a positive. So my final simplified answer here will be positive. 18 divided by 6 is 3. And then I'm not dividing any of these variables. There's no variables, there's no x, there's no y in my denominator. So this just stays x squared y. Then I've got, keep having to write this, minus 8x cubed plus 12x squared y plus my 3x. Only once I have simplified every single term as much as possible. So all my terms are simplified. Only now do I look for like terms. That's not how you spell simplified, is it? Simplified. So this looking for like terms or this checking for like terms should basically be your very last step before your final answer. Only once all of your terms, and yes, I'm going to come back to the question, don't worry, I'm just giving myself a bit more space here. Only once all of your terms are simplified as far as possible do we now start looking for like terms. Right, so we grab our highlighter. Let's see what we can find. We've got a term with an x squared y. I've got another term with an x squared y. Remember, like terms, same variable or variables with the same exponents. So both of these terms have an x squared and a y, so they are like terms. The next group that I have is then just the x cubed terms. They don't have y's, the x's are cubed. It's a group by itself. And then as a separate group, we've got our 3x. Importantly, 3x and negative 8x cubed are not like terms because the exponents are different. One is an x cubed, so an exponent of 3. One is just an x, so an exponent of 1. Because those exponents are different, they are not like terms. So now we can add and subtract our like terms. We have got positive 3x squared y, so the purple ones that I've highlighted or underlined, plus 12x squared y. 3 plus 12 is 15, x squared y. Remember, as we said in this example, when we add and subtract like terms, the exponents do not change. So my exponents are exactly the same. Then I've got my minus 8x cubed plus 3x. I can't do anything with those final terms. They aren't like terms to anything else, so they just stay there. So as a reminder, these terms have come from me simplifying my like terms. And so each of those have come from the simplification. There's no more like terms in this expression, so this is my final, that is my final answer. I have simplified, I have looked for my like terms, I see there's no more, and that's it. Right, Zibonga, just quickly, when you say the distributive law on the first term, if you are meaning that you went and you said 3xy times negative 4x, 3xy times negative 2, that's absolutely fine. It means that you'll deal with your fraction a bit differently, but it's absolutely fine. Yes, just remember you do have like terms there, and if you can add them first, it does make your life easier, but that is absolutely fine. Neo, yes, I got the minus 6x by adding minus 4x minus 2x. So yes, those like terms got me negative 6x. Well done. Right, so grade 8, I'm just going to make that a touch smaller for you. Take your screenshots. If you have questions, you are welcome to raise your hand at this point. You guys are doing really, really nicely. Right, Tingo?
Hello, ma'am. So
Hello.
the way I was taught at school, ma'am. So then for positive 3x, we'd move it by negative 8x to the power of 3. Then we'd move x 12x to the power of 2y by 3x to the power of y, 3x to the power of 2y. Then
So you would do something along these lines. So you would say 3x squared y plus 12x squared y minus 8x cubed plus 3x. So you would group your like terms.
Yes, ma'am.
That's absolutely fine. Sorry, usually I do that. I just didn't. But yes, that's absolutely fine if you want to group your like terms so that you know what to add and subtract.
Okay, ma'am.
Okay, Sibasiso?
Hello, madam.
Hi.
Madam, can I please ask how do we get the negative 18?
Okay, cool. So the negative 18, if you go down, oopsie daisy, sorry. If you have a look at this blue block over here, so this blue block was the distribution or the multiplication between the 3xy and the minus 6x. So positive 3 times negative 6 is negative 18. X times x is x squared. And then we've just got the y by itself, so that's why we get x squared y. The negative 18 has come from saying positive 3 times negative 6. That gives us that coefficient of negative 18. Okay, guys, I do see your hands. I'm not ignoring you. I'm like, there's a lot of you with hands up. Like, we all give each other a turn. Wami?
So, ma'am, for the first term where it says 3xy with the brackets,
Yeah.
so we don't distribute it.
You can distribute it, like I've said, but if you've got like terms like we had in the bracket, it's easier to do the like terms first. But if you distribute it, you will get the same answer.
Yes, ma'am.
Okay. Right, Ortile?
Ma'am, can you hear me?
Yes.
Okay, I wanted to ask you about the equation. I saw that by adding the 3yx, the positive 3yx into the 6x gave you 18 squared. I wanted to ask you the different way. Is that a way of using bodmas or bodmas? We started first with brackets. You used the step, you started with the first term, you distributed the first term, then the second term, you distributed the second term, the third term, you distributed it, and that combined you the answers. Is that the method that you should use? You distribute them before you answer them.
When you say answer them, what do you mean answer them?
After distributing them, you can
Then you can
simplify.
add your like to. Yeah, that's
Yes.
absolutely fine. So if you had done that rather, so I'm just going to do it in this little block here, and you had distributed 3xy, you would get minus 12x squared y minus 6x squared y, all still over negative 6. Those are then like terms. So if you simplified that, like you say, you would then get the minus 18x squared y over negative 6. So you end up in the same place anyway. So that's why I'm saying if you would prefer to distribute first, that's absolutely fine.
Okay, thank you.
Sure. Right, just there's some questions. Firstly, how did I get the second term? Guys, the second term, you need to look at the purple block. The second term was the distribution. So if you have a look here, this is the purple block to which I'm referring. You are distributing the minus 4x to the 2x squared and then to the negative 3xy. So that is how we get the second term simplified. And then there was a question about how did we go from minus 18x squared y to 3x squared y? I simplified. Negative 18 divided by negative 6 is positive 3. So I simplified my fraction and I then could work from there. All right. Atlahang. Remember, guys, 5 second rule. If you don't answer within 5 seconds, I'm going to move on. Sorry, Atlahang, yes?
Sorry, I've muted Atlehang. Sorry, Teacher Sam. I would just like the rest of these people here, try to type your questions also on the chat so that we can finish and you can move on, because we can't get stuck by answering all of each of these questions. Okay, so please make sure that you also put it on the chat. While you see Atlehang is asking a question, it's okay, it's Atlehang's question and we are listening. But if you see that it's not what you wanted to ask and your hand is up, please lower your hand and try to put it also on the chat. Okay, so I can help Teacher Sam and then we can move faster. Sorry, Atlehang. I will unmute you now and then you can talk.
And guys, on that, please listen to each other's questions. Like, listen to what Atlehang is about to ask so that you're not repeating questions. Atlehang, you still have a question?
Yeah, Atlehang, I don't know where did you go. Just on the chat also, please don't panic about load shedding. Everyone knows that it's load shedding, okay? But we are reading the charts and I don't want to miss anything on the chart. So please, let's stop commenting about load shedding. We know. And we are recording this lesson for you so that you can watch it whenever you have electricity, okay?
Exactly.
So please, let's not make quite a huge thing about it and then we miss what Teacher Sam is actually teaching us today, okay?
All right, Kelsey?
Ma'am, how did you get in the answer 15x square y?
Okay, so that has come from adding together my like terms of the x squared y group. So 3, if you just look at the coefficients, 3 plus 12 gives me that 15. And then I've got the x squared y, because remember the variables don't change when I add or subtract them. So it's going to stay x squared y, but the 3 plus 12 gives me 15.
Okay, thank you, ma'am.
Good. So guys, that's very important. When you add and subtract, the exponents stay exactly the same. Atlahang, we did try, but then you disappeared. So I don't know what happened. Alamina, I hope I'm saying your name correctly.
Ma'am, you see, ma'am, the last equation, can we just leave it like that, or can we simplify it further?
So when you say the last one, do you mean this one here with the purple arrow?
Yes, ma'am. Can we simplify it further, and why can't we simplify it?
Okay, so we can't simplify it anymore because there's no more like terms. None of them are like terms. So I can't add or subtract any of them. So that's where I stop.
Thank you, ma'am.
Okay. Alrighty, guys. I'm going to move on because I would like to do another example before we end. So all of you with your hands up, please lower them, but please put your questions either in the chat or send them directly to myself or Yolanda and we'll help you. Sibosiso, I don't know what you're asking, why not? I'm assuming you're asking the why not about why can't we simplify further from this last step. I have just said it. There aren't any like terms. All right, guys, I hope you all got your screenshots. I am moving on to the next example. We've got a bit of chaos going on here, so let's just get rid of that for a second. Okay, so have a look at this one. I don't even, it says A, but it is C. Have a look at this one and tell me quickly in the chat how many terms are in this expression. Remember, terms are separated by plus and minus signs outside of a fraction or a bracket. So how many terms do we have here? Nice, guys. Well done. I'm so glad we're starting to listen. Good. Okay, so we have got 3 terms. I'm going to identify them for you now. Our first term is the fraction. Let's go here. Here's our fraction. So first term, this plus sign is separating it from our second term, which is the xy squared times the bracket. And this minus sign is separating from the third term. So we've got 3 terms here. Remember, what we want to do is we now want to go and just make sure that all of our terms are simplified. So from my first term, I've got a fraction. Now, let's just draw a little block for ourselves. So if we're going to simplify this first term, we are going to have to deal with the division. So we've got minus 12x cubed y to the power 4 all over minus 3xy squared. Okay, so remember, guys, SNV. This is going to be very helpful for us. Signs, numbers, variables. A negative divided by a negative is a positive. That's my sign sorted. Numbers, so the coefficients. 12 divided by 3 is 4, numbers sorted. And now I go to the variables. Now remember, when you are dividing, so here we've got x cubed divided by x. When you're dividing with the same base, we subtract the exponents. So this would be x to the power 3 minus 1, which gives me x squared. If you don't really like that, you can cross cancel. So 1x at the bottom cancels with 1x at the top, leaving me with 2 x's. Either way, you are getting x squared as your simplified answer. If we then have a look at y, very similar thing. Either you say 4 minus 2, so you subtract the exponents and apply your law, or you cross cancel, whichever you want, but you end up with y squared. So this very first term simplifies to positive 4x squared y squared. Now we need to go and have a look at our second term. So our second term here is this multiplication. So if we again draw a block for ourselves to work it out, we've got xy squared times negative 4x and xy squared times negative 2x. Now this is an example of doing distribution before you simplify like terms. These are like terms, so if you wanted to add or subtract them first, that's fine. But if you didn't realize that, you will get exactly the same answer. So I'm just going to show you how to do it like this as well. So we've chosen to distribute. Positive times a negative is a negative. Remember, there's a 1 in front of those xy squared. So 1 times 4 is 4. X times x is x squared. And then you've just got the y squared sitting by itself. It's not been multiplied with anything, so I can't actually do anything with it. So we're just left with y squared. In my second multiplication, positive times a negative is again a negative. 1 times 2 is 2. X times x is x squared. And then the y squared again, I can't do anything with it, so it's just y squared. So I have got minus 4x squared y squared minus 2x squared y squared. Hopefully what you see is that if we didn't see these like terms here, I now still have like terms once I've distributed. So the like terms haven't gone anywhere. It's just I'm dealing with it in another step rather than initially in the first step. If you do deal with the like terms, that is absolutely fine. Okay, last one, can't do anything with that. It's just minus xy because no multiplication, no division is what it is. I've simplified everything. Now I check for like terms. Now, hopefully what we're seeing here is that I've got quite a few like terms. Here's an x squared, y squared. There's an x squared, y squared. There's an x squared, y squared. So those first three terms are actually all like terms. They all have an x squared and a y squared. Unfortunately, this little term right at the end here, it's by itself. There's only one xy term. Remember, both of those have an exponent of 1 that's not the same as x squared, y squared. So now when we simplify this, 4 minus 4 is 0. 0 minus 2 is minus 2x squared, y squared. Remember, those exponents don't change. Minus xy. No like terms, can't do anything with that. That is my final answer. Okay, so very importantly, identify your terms, simplify your terms, then only look for like terms.